Hello, my name is John Leone, and I would like to welcome you all to my presentation. My presentation is on the prototype design pattern. I hope you enjoy it. The intent of the prototype design pattern is to allow programmers to easily create new instances of a class by simply copying an existing instance. This saves on resources and can also save development time. This is used when creating multiple instances of something is required, and if done the traditional way, is time-consuming and takes up many resources. The prototype design pattern allows programmers to make one instance of something and then just clone it, which is much less time-consuming and resource-intensive. A lot of modern games use the prototype design pattern. They use this when the creation of an object, such as a character model, is expensive, whereas cloning is much cheaper. This is commonly used when enemies are instantiated. If a numerous amount of the same kind of enemy is needed, one instance of the enemy is made and then cloned multiple times. Most games that use bullets or other kinds of projectiles also use the prototype design pattern. These games could create the first projectile and then create multiple clones of that creation. Here is a UML class diagram of the prototype design pattern. Now, onto the structure of the prototype design pattern. The client tells the prototype class to clone itself and create an object. The prototype is an interface and it declares a method for cloning itself. The concrete prototypes implement that method to clone themselves. These next 3 slides show the prototype design pattern in action through the source code. In a few slides, we will see what happens as a result of running the source code. The top constructor takes a very long time to instantiate a vehicle because it has to perform highly expensive calculations. On the contrary, the constructor right below that one only just copies the data, which is passed into the clone function. This makes cloning much faster than creating a new instance from scratch. This right here is my main function. The instance for the first car is created and then copied twice, once for each racer. Here are the results from running the code from the previous slides. It took much longer to instantiate a car than to clone it due to the initial instantiation requiring more expensive calculations to be performed. Here are some of the advantages of using the prototype design pattern. It reduces the amount of subclasses needed to be made. A new concrete product can be incorporated into the system by registering a prototypical instance with the client. You can specify new objects by varying values and structure. Here are some more advantages. The prototype design pattern is useful if an object that needs to be created needs to only be slightly different from one that already exists. Also, as I previously mentioned, this design pattern saves time and resources if multiple clones of a class instance need to be created. Unfortunately, every design pattern has its own set of flaws. Here are some of the disadvantages of using this design pattern. Using the prototype design pattern can very much be overkill for projects that do not use many objects. Concrete classes are hidden from the client. The clone method can be difficult to implement when the specified class already exists without the clone method. Every one of the prototype classes' subclasses must implement the clone method, which can be hard to implement when the specified classes already exist without it. Here are the last of the disadvantages to using the prototype design pattern. Cloning can get way too complex if there are multiple classes that need to be cloned. Also, it can be very difficult to clone classes that have circular references. Here are the resources I used. I sincerely hope you enjoyed my presentation.